is what we're concerned about is that maximum distance from here to here. If we have 45 pounds of pressure through one tube, we know we can go 615 feet with 45 psi in that one tube. We still are going to have 45 here, and it's still going to go down there and still be fine. Okay. It's not all of the tubing together, it's just this. Now, what would impact this being longer or shorter? If this was going up a hill, then it would be shorter. If it was going down a hill, it could be longer. So take that into consideration when you're dealing with slopes. Okay? So are we good there? So just because I made a new friend here today, that we have friends in common, I'm going to ask you to come down and design this next one for us. Okay? And we're all here to help you. Okay? So we're going to do grass. And we're going to do clay. So we need to know emitter flow rate, emitter spacing, row spacing. We need to know GPM. Okay? Are you ready? So now is what we've done is it's the exact same one. We're going to go grass in clay soil. It's now 1,100 feet long, and it's 10 feet wide. So I kind of helped you out here on figuring out which ones it is that we need to do. So we need to figure out our emitter flow rate first. So what emitter flow rate are we going to choose? Page 8.
I have that right here.
So grass, and then clay.
It's going to be 0.26.
Okay. So 0.26 GPH emitter. Okay. And then what's our emitter spacing? 18 inches. What's our row spacing?
18.
Okay. So now we need to figure out how much tubing and our total GPM and all of that other fun stuff. And please, we can all help, right?
What is the app you're using called?
Pardon?
What is the app you're using on your phone? What is it called?
It's only for iPhones. We don't have the Androids yet.
That's fine.
But it's NetFM Landscape Calculator.
You have to pay for it, is that what you said?
No, it's free.
Oh, cool.
Totally free.
Where are you on that Android?
Probably about 2 weeks. Hopefully by the end of semester, right?
Yeah, right?
And we do have a calculator that you can download for your laptop. But I don't know if you can open up your laptop on your test. I don't know. We'll see. Right? So what's our total square footage that we have here? 11,000. Okay, so we need to figure out how much tubing that we're going to need.
I got 7,370.
7,370.
Yeah.
Okay. So now we need to know how many emitters that we have, right?
Yeah, I got 4,938.
4,938.
Yeah.
She doing good so far? Yeah. Okay. So now what is that? Now what do we do with that?
We take that and times it by our emitter flow.
Okay.
which equals 1,284.
1,000 what?
1,284.
Okay. And that's GPH, right?
Yeah.
Now what do we do?
Divide that by 60.
Okay.
Equals 21.4 gallons per minute.
Perfect. So we are at 21 point what? 4?
Yeah.
Okay, now the app said it's 21.18, so close enough, right? Okay, so now what do we need to do we need to lay out our tubing and figure this out, right?
Yeah.
So let's say that we, two scenarios. One is out of one connection we have enough water to run this under one zone.
Okay.
And let's also make the assumption that our microclimate for this is all the same. It's a median out in the middle of the street. Everything is consistent. Where are we going to put our headers at on this? Where would we like to put our headers at on this?
Probably the ends.
Okay. Can we do that?
No.
And how do we figure that out? And why or how do we figure out that criteria?
Well, we have to figure out the PSI.
Okay.
And even at the highest PSI, we can't. Oh, no, we can't. We can go only to 840 feet.
Okay, 840 feet. And we're at 1,100 feet. Do you get that? Where we're at there? So can we do it?
No, we have to put one in the middle.
Very good. Center feed header. Very good. So now is what we do is we create a center feed header. Okay. Now is what we can do is we feed it from the middle, and as long as we size this pipe to handle the flow rate for this entire zone, we can go 840 feet that direction and 840 feet that direction. So we cover so then we'll have a center feed header here and then an exhaust header here. And on both of these, we will put a flush valve on both of these exhaust headers. Okay? So what size of pipe does this need to be? And let's say that we can't exceed the 7.5 feet per second on schedule 40.
I'm gonna need this. Team, anyone know?
So it's the shaded area, and just before it transitions into the next shade is typically where you want to be at. So
it'd be, you have it at, which was 21, right?
see, I don't have my glasses on, so I can't even read that.
2-1.
What's that?
Oh, sorry. 3/4.
No, we need a larger pipe than that. I do know that on 21 inch.
1/4, right?
So what's our?
Would be,
There's our velocity. So this number here, as soon as it goes to 7,
oh, so we need a 1 inch, right? Because that's 7 right there.
yeah.
So we need a 1 inch.
So see how there's that lighter color on the velocity per second in there, and I said you couldn't go over 7.5 feet, so you just go right down to 7.5, or that number before it changes, and that's actually where it changes colors. So it's that tan color, so we know that it's the 1 inch. Does that make sense? Can you see that?
Somewhere in there, Google House takes behind the shade area. He's using 7.5, but we go for 5. So it's 5 or 7.5, and you're saying it's typical to use 7.5.
Yeah, so if it's 5 feet per second, what would the size of our pipe be?
1.25.
1.25, okay? Our supply headers and our exhaust headers are always the same size. Okay, so whatever sizes we're looking at, so this will be 1.25 for 5 feet per second, or 1 inch on both of those. Okay, so let's say now, let's change this up. Let's say that we only have 8 gallons a minute per zone. How are we gonna divide this up? Basically, we're going to divide this by, we have 21 gallon, 8, we're going to have 3 zones. So basically is what I would do is I would take this 1100 and I would divide it by 3, and I would just come up with 3 equal areas. And then have a header here and a header here and a head, you know, 2 sets of headers. Okay? And then I'd have a flush valve on the supply headers and exhaust headers. Does that make sense? What we did there?
No, I missed it.
So if we know that our total flow for this whole area is 21 gallons a minute, but our tap, our connection is only 8 gallons a minute. That's all that we can get out of it. So we know that we need to divide this into 3 zones. So basically is what I'm going to do is I'm just going to divide it equally by 3 and create my headers that way. Does that make sense?
So where'd you get the 8 gallons?
I just made it up.
Oh, you okay.
Just made it up. 8 gallons a minute is a pretty typical residential type of thing, so it's a number out there. Okay. Good job. You gotta have a donut though before you go sit down.
Oh, okay.
No, you don't have to. I'm just kidding. Okay. So now let's look at this one here. Let's say that our soil is sand and we're growing turf. And as what these are like 3 medians out in a parking lot. Okay? So is what we're going to do is we'll have a valve, filter, and pressure regulator. And we're going to run a pipe that's going to come out and come through each of these, and then we'll stub up into each median. Okay? So if sand and turf, what's our emitter flow rate?